Hello guys and welcome to Mossy Maths with me, Tom Moss, and in this lesson we're going through circles again. It's the second lesson and we're rearranging circle equations. And what I mean by that is we have to get a circle in this equation here, x minus a squared plus y minus b squared equals r squared in this form with a centre AB. And we do that so that we can then find the centre and radius of the circle. Now, having recently sat my AS exam, these questions here are very important, and with the last lesson that was sort of a build up to this sort of thing. This is certainly a common type of question you could get in a Core 1 exam, and having gone through many past papers there are plenty of these kinds of questions and they're always in this kind of form. So if you learn the method for solving this type of question, hopefully you'll be able to pick up full marks if you do see this type of question in your exam. So part A says the equation of a circle is x squared plus y squared minus 6x plus 4y plus 4 is 0. And we're told to find the centre and radius of that circle. So, when we go about solving this, we have to get the circle in this equation form so that we can then identify the centre and radius of the circle easily. So how do we get this in this form? Well, what we do is we complete the square, and we have to consider both the x and y values. So, considering the x values, what we have is x squared minus 6x, just considering the x's. So if we were to complete the square with this, you should know we just do x minus, then we halve the coefficient of x, which becomes 3, and then square it. Now, if you're not familiar with this, then I suggest you go back to my previous lessons on quadratics, where we actually look at the method of completing the square. Okay? So we halve the coefficient of x and write it inside the brackets, and then we square it. Now, the next thing we do is we look at what we've just completed the square with. Well, we don't have a constant. This is just the x terms. So when we expand this, what do we get? Well, we get x times x, that's x squared, minus 3x is indeed minus 6x, but we also get minus 3 times minus 3, which is positive 9. So we get 9 when we expand this, and there's no 9 here. So we've actually created a 9 from nowhere, effectively. So we need to get rid of that so that it's in this form. So if we get positive 9 when we expand this, and we don't have anything here, we have 0, then we need to minus 9 to get back to 0. So this is the same as this, okay? Minus 6x, x squared, positive 9, subtract 9 gets us back to 0. Now let's consider the y's. We have y squared and we have plus 4y. Let's complete the square with this. Well, again, we do the same thing. We halve the coefficient of y, which is going to give us positive 2. Again, we have a positive sign here. We square this, and then looking back at this, we don't have a constant, we just have y squared and 4y, which we do get, but we also get 2 times 2 when we expand this. 2 times 2 is 4, and we need to get back to 0 because we don't have any constant term here. So to get from 4 to 0, we subtract 4. Okay? And this is the same as this. So we can now rewrite this equation with these two forms. X minus 3 squared minus 9 plus y plus 2 squared minus 4, and don't forget the constant we have on the end, plus 4 equals 0. So now we rewrite this and we collect the constant terms together. Minus 9 minus 4, well that's minus 13. Minus 13 plus 4 gets us back to minus 9. So overall we have minus 9. And hopefully you can see what's going on now. All we have to do is move this minus 9 across to become a positive, and we have this equation in this form. So we get x minus 3 squared plus y plus 2 squared equals 9. And now we have it in the form x minus a squared plus y minus b squared equals r squared. So the centre we can easily identify. If you're not sure how we do it, again look back to my previous video. The centre is just the opposite sign to what we have in each bracket. So we make each bracket equal to 0 effectively. So we get 3 as our x value and minus 2 as our y value. We just swap the signs. And our radius is the square root of 9, which is 3. And you could say it's minus 3, but the minus 3 is irrelevant, because a radius, of course, is just a distance, and we can't have a negative distance. So 3 is our radius. Okay? Our radius squared is 9. Looking back to this equation, r squared. And so our radius is the square root of 9, and we take the positive of that. Now let's move on to the second question. If you like, you can pause the video and have a go yourself. It's a very similar question, however, when we complete the square, we're going to get a fraction. So we're probably looking at an extra mark for this question. So hopefully you've paused the video and had a go yourself. With this question, it says the equation of another circle is x squared plus y squared minus 5x minus 5y plus 10 is 0. And we're told to find the centre and radius of the circle. So the centre and radius is just, again, getting this in the form of this equation. So to do that, we complete the square again. We consider the x's first. So we have x squared and minus 5x. When we complete the square, we halve the coefficient of x. So we get x minus, because it's a minus here, and we halve 5, which is going to be just 5 over 2 as a fraction. Then we square this, and then again, we have to subtract whatever we get when we multiply minus 5 over 2 by itself, minus 5 over 2, because we're squaring it. So we're going to get a constant term, and we don't have one here, so we need to subtract that to get back to 0. Well, minus 5 over 2 times minus 5 over 2 is minus 25 divided by 4. Positive 25 divided by 4, because we have a negative times a negative. And we then subtract that to get back to 0. So we have minus 25 over 4 outside the brackets. So hopefully you can see how we got that. 5 times another 5 will give us 25 on the numerator, and 2 times another 2 will give us a 4 on the denominator. We're just timesing this by itself, and we get that. We subtract that then to get back to 0. We now consider the y's from this question, and we have y squared, we have a minus 5y as well. So this is very similar. Minus 5 over 2 again, halving the coefficient of y, and we're going to get the same answer when we square minus 5 over 2. Okay? So now let's rewrite it. We have x minus 5 over 2 squared minus 25 divided by 4 plus y minus 5 over 2 squared minus 25 over 4. And don't forget the constant term, which is positive 10 equals 0. And we now simplify this by collecting the constant terms together. Okay? So we get x minus 5 over 2 squared plus y minus 5 over 2 squared again. Now, we need to collect minus 25 over 4, minus 25 over 4, and positive 10. Well, minus 25 divided by 4 minus 25 divided by 4 is minus 50 divided by 4. And then we're adding 10. Now, the way I'm going to write the 10 is with 4 on the denominator, so we can easily add the fractions. Well, how can we make 10 out of 4 to still get this? Well, we can make it 40 divided by 4, can't we? Because 40 divided by 4 is just 10. So if we write 10 as 40 divided by 4, we can easily add the fractions together. And by doing that, we're going to get... Now, I am going to skip a step here for the sake of space. I'm going to move it across straight away. Minus 50 divided by 4 plus 40 divided by 4 is minus 10 divided by 4. If we move the minus 10 divided by 4 across, we get positive 10 over 4. Now 10 over 4 is the same as 5 over 2. So I'll jump to that step as well. So all we're doing is adding these together, we get minus 10 over 4, we move it across to get positive 10 over 4, which is the same as 5 over 2. And now we can find the centre and radius, because we've got this in the form we need it. the centre is just going to be 5 over 2, 5 over 2. Okay? We just swap the signs for each. I mean, that is 2.5, 2.5, but we need it in its simplest form for a Core 1 exam, so a fraction is simpler than a decimal. And then the radius is going to be 5 over 2 square rooted, because this is our r squared. 5 over 2 is r squared, so r is going to be the square root of 5 over 2. And we leave it in this surd form, because we're going to get a decimal when we find out the answer to this, but we can't use a calculator. This is a Core 1 exam, so we're not allowed a calculator. So we just leave it in the surd form 5 over 2. Now the problem with a Core 1 exam is you could easily get a question like this, and you might doubt yourself because you'll get an answer like that, the square root of 5 divided by 2. And it looks like you've done something wrong because you'd expect to get an integer as an answer, a whole number. But that's not necessarily the case at AS level. You could get an answer in this form and you could have done it right. It's always worth checking if you get an answer like this to see if you have made a mistake. But if you get the same answer again, then trust yourself that you've done it right, because in Core 1 you can get these kinds of answers. And you will probably get more marks, so it might be a good idea to look at the mark allocation for the question. If you get more marks than you'd expect, then most likely you're going to get an answer in this kind of form. Okay? So that's lesson 2 on rearranging circle equations. If you found the video helpful, please put a like. If you do have any questions, then leave a comment and I'll get back to you as soon as I can with a response. Hopefully you understood what we did there. In the third lesson we'll be moving on with the topic of circles, and then after that we'll be starting a new topic on simultaneous equations, which will be the last topic of Core 1. So thanks a lot, and I'll see you in lesson 3 on rearranging circles.